Guys, so this is the video to review how to solve systems of linear equations. Now, it is extremely important that you understand how to do this because right out of the gate in chapter 1, we will solve this, but instead of having 2 variables, we're going to have 3. So it's going to be a lot more complicated than this. So if you don't know how to do this and you don't master this now, you're going to be lost when we do 3. And once again, like I said, that's in chapter 1 and just next week. Okay, so here we are going to use substitution. Okay, so when we use substitution, we want to write one of these equations in either x equals or y equals. Okay, now I see this right here, and this makes me excited because I know that if I just add 8 to both sides, okay, 8x, I can rewrite this equation as y equals 8x minus 12. Okay, so everyone should be able to recognize that this here and this here are the same equation, just written differently. Okay, so now that I have that, now I can substitute, hence substitution, the 8x minus 2 in for y. I have to do it into the other equation. Okay, so I could say 4x plus 3, and I know my y in terms of x is 8x minus 12, and that has to equal negative 8. Okay, now I've created an equation that's a little longer, a little scarier looking, but really it's not because I just have one variable in it. So if I clean this up, 4x plus, remember to distribute this, 24x minus 36 equals negative 8. Well, 4 and 24 is 28x minus 36 equals negative 8. Add 36, I get 28x equals, this is 28. So when I divide by 28, I get x is 1. Okay, so I know that if my x is 1, I can plug x is 1 into here to find my y. So my y is 8, my x is 1, minus 12, which is just 8 minus 12, which is negative 4. So my y is negative 4. And we would actually write this as an ordered pair. So with my x value is 1, my y value is negative 4. This is how I'd write it. So this here would be my final answer. All right, let's look at another example. In this one, I want to use elimination to solve this. So when I use elimination, I eventually want to add these two things. And I want to change it to where that when I add the two things, one of the variables is going to eliminate. Okay, so I notice that if I multiply this by 2, okay, I would get negative 10x plus 6y equals negative 18. Okay, and this are the same. Remember, I can do whatever I want to the left as long as I do the same thing to the right. I can multiply 2 on the left as long as I multiply 2 on the right. Okay, now I'm just going to write this equation unchanged right above it. So 10x minus 8y equals 4. Okay, now when I add these, well, my 10 plus a negative 10, these eliminate, hence the elimination method. Okay, 8y plus 6y is negative 2y. This is negative 14. So if I divide both sides by negative 2, I get y equals 7. Okay, now after I know one variable, I can plug it in to get the other. So you could use either one of these, it doesn't matter. I'm just going to use this bottom one. So negative 5x plus 3, I know my y is 7, so I can substitute 7 in for y equals negative 9. So negative 5x plus 21 equals negative 9, so minus 21. X equals negative 30, so if I divide by negative 5, I get x equals 6. Okay, so once again, x is 6 and y is 7, so to write it correctly, I would write it as an ordered pair, so 6, 7 would be my solution.